Hello and welcome everybody. In this video I will go step by step through the process of creating our first robot client application for the social interaction cloud, and we will use the basic connector and the action runner, which is part of the action code base here. And we will create a simple application where we will let the robot go stand up and go back to crouch again in several different iterations. So for this video, I assume you already installed the Social Interaction Cloud following our wiki instructions and also connected a robot to it and obviously started it up on your laptop. So what I did, I called docker compose op dialogflow and I started the robot installer to make sure all the scripts are installed on the robot by connecting it here. So as you can see, everything is connected successfully, and this I will use as a starting point for this video. So let's go create our first application. So this is my first application, and I will create a class, my first application here, and what we need is of course a reference to the basic connector, because I will be using that to make it more simpler. So I will just call it the Social Interaction Cloud is basic connector. We will need to import that, and it needs a server IP. So that's something we will call here, which will be a simple string. And action runner from the action class here, so I will just create a class here called an action runner. I will just import that here, and I will need the reference to the basic connector here if you want to use it, so I will just pass that along. So these are the things that I need at the moment, and I will just create a run method to run my program. So the first thing we always do is to start our connector to really set up the connection and keep the thread running, and we always close when we're done also with the stop command, so I will put them in here. And maybe a fun thing to do now is to just create a hello world action here. So I will use the runner, the action runner, and I will run a waiting action. So what I need here is I will put the method name in a string form here. So I will go to the basic connector and look at what method I will be using. First I will use the say command, and it has a text as an input and an optional callback, so I will be using that method. So I will just put say here and then the text that I want to say, for example, hello world. So what I need to add here before running this is to make sure it uses the English language. So I will add another run waiting action. I will go to the basic connector and see I need set language and then the language code. So I will use set language. I just copy pasted that there, and I will just add the English language tag, which uses this format, just the basic format for setting languages. So now it will set the language, and because I'm using a run waiting action, it will wait until that action is finished. If I don't, if I delete this and I have an action and it was already set on Dutch, it might not already switch the language, and then it will say hello world or whatever you type there in the Dutch language. So if you have English text, it sounds really funny. So that's one of the reasons why we introduced the waiting actions here. We want to wait until it's finished before continuing. And also the same thing with hello world. If I remove the waiting action, and in this case it will go fine because there is no things afterwards, but what will happen is that while it's saying the program is already stopped, so which might create some errors at some point if there is still, if the social interaction cloud connector is already stopped, but the robot is trying to push certain events or results, then they might not be delivered, and sometimes it's not a problem, and sometimes it creates errors if there is unexpected data receiving. So now we have a simple class with one simple method, namely a run method that changes the language to English and says hello world. So I can simply run this method, and I will just my first application. I will make an instance of this class. I will give the IP address, which is the basic IP address I can find here. Because I'm using the Docker desktop, you might need this one if you're using the toolbox. So I can just copy paste that here. So I create an instance, and then I will call the run method, not the runner method. Let's just see what happens here. I will run my first application, and then I will get this screen. I will select them all. I will just hit OK. And it said hello world from the robot. So this is all working. And the program is also gracefully exited, which is nice. So let's move on to creating a robot that changes position. So important to know is that the robot cannot move if it's in a sleeping state. So we first need to wake up the robot in order to make it move. So that's where the wake up command comes in. We will let the robot wake up. And you simply use the wake up method. And before stopping, we will call the rest method. Let's see what we need to do to make the robot move. We go to the basic connector again, and we see I go to posture. Is something we want to call. So let's do that. And to show you parallel actions, I will make it say something while it's changing position. So I will just load certain actions and then execute them in parallel. So instead of run, I will now load a waiting action, and we'll use the say action here, and I will make it say I am going to crouch now. Why crouch? Well, wake up. If you start in a crouching position, which I recommend to do at all times, when you start an interaction, just put the robot in crouch, then call wake up, making the robot stand, and this, and then we will have the standing position as the starting position, so we can make it crouch and stand up again for the purposes of this demonstration. I will now load the go to posture action and add the posture, and the posture is actually an enumeration that has been defined in the basic connector on top here. So we need robot posture dot crouch as the parameter, robot posture dot crouch, and we need to import that as well. Now I will call the run loaded actions method to actually run these two in parallel, and we see here an optional argument which is called clear, and it's a boolean and its default is true, which means that the loaded actions are cleared immediately after running them, so we can just load new ones after this, and these the crouching go to posture method call has been removed by then. If we want to create packets of reusable information, we can just create a new instance of the ActionRunner method, and whenever we load a bunch of actions or waiting actions that we want, and then whenever we run the loaded actions, we just hit clear is false, making it preserve the loaded actions, and we can reuse them actually. In this case we won't, so we can just go with the default, which is true, so I can do other stuff like the run waiting action here without interfering with the loaded actions previously. So what I want to do now is making the robot go back to the standing position. So I will just simply copy paste this. I'm going to stand now, call this, and this will make the robot first say hello world in English, then it will wake up by activating its motors and going to a standing position, then it will go back to crouching position in an active awake mode, which means that the motors are on and you cannot freely move the joints. Then it will go back to a standing position, and then it will go to a rest position, which is basically the crouch position with its motors off, and then this program will stop. And let's see if we have succeeded with this implementation. Let's run this program.
Hello world.
Yes, hello world. It will go to an awake state.
I am going to crouch now. I am going to stand.
So these actions are run in parallel, and then it goes to sleep again. So success, and this is our first iteration of this program. So what we might want to make it more fancy and use some other examples of our code. So what I want to do now is I want to make it stand and go crouching again, by just pressing the button. So I will need an event touch listener for that. And I want to make some reusable code, which works slightly different. So just let's move to that step by step. So I want to add a touch listener. So I want to actually just activate it immediately. So I want to register a touch event here, and I want to activate it whenever I touch the middle button on the head of the now. So let's move to the documentation of the now. I clicked here, and I have an overview of all the components here. So I will just look for the touch part of the API, and then I see the event list here, and I see middle tactile touched. So that's the event that I'm looking for. So I will just copy that. I don't need the brackets there. For the touch event, I'm going to add middle tactile touched like this. And then I want to add a callback where I change the posture. So I need to create that. So what's important here to realize is that we can we can choose of an optional if it's continuous or not. So if the default is not, so it's a single use touch listener by default. So if I want to make the functionality repeatable and reusable, we need to set continuous to true. So which way I will do here, continuous is true. Now I will create the change position. So I will just create a new class here, change posture. And what I want to do here is move the robot. If it's crouched, I want to go make it stand, and if it's standing, I want to make it crouched. So remember that in the basic connector we had the robot state, which contains its posture, which is automatically updated after posture is changed. So I can use that information here, and I can access it through here, through the social interaction cloud connector. So I will just make an if statement stating that if the robot state, well, the posture in that dictionary at least is crouch, I want to make it stand. So I can copy this code here, or I can make it into a reusable code that I can use at different positions as well. So I will actually remove this part of code here. I will move it to my init, and instead of the runner, I will create a different one. I will create one, for example, so this is the crouch one. I wanted the stand one, so I will move this also here. I need both anyway, so I will just start with the crouch one here. Go to crouch runner, and we just make a new ActionRunner instance here. Copy that here. We don't want to run it here, so we will remove this. So we now have a separate instance of ActionRunner that contains the I'm going to crouch now and actually goes to the crouching position. We will do the same thing here. We'll create a go to stand runner. Another instance, and again we don't need this one. So what's important to know at this point, this is something that needs to be optimized in a future version of this code, is that the waiting action that is linked here will actually hold the thread that it's been activated on, and because we're gonna use this in a callback function here, it will actually hold not the main thread but the thread where the callback function is being called, which is the wrong thread. So currently we're not able to use waiting actions whenever whenever we trigger them in callback functions, but for this functionality we don't need to do that. We don't need to the main thread to wait on these actions anyway, so we will change this in regular actions. So I will remove the waiting part of it and we will just load regular actions here. And these will be, whenever we run this go to crouch runner or go to stand runner, it will run these in parallel. So now we can actually do that here. So if it's crouched, we want to make it stand. So I will run the go to stand runner. I will run the loaded actions, but important here is that we change clear to false, because when we will use this repeatedly, so we don't want to clear it and keep it active. And the same thing goes here. If the robot state, or at least the posture part of it, is standing, we want to trigger the go to stand, go to crouch runner here, run the loaded actions, and also clear is false. So now we have a bit of code here that whenever this callback function is triggered, it will look at the current state, and if it's crouching it will go to standing position, if it's standing it will go to crouching position. So if we look at our program here, what it will do now is it will change the language to English, say hello world, will stand up and wake up, and then whenever we touch the middle tactile bottle it will change position. However, what happens afterwards, directly after registering this listener, it will go to rest and stop, because the main thread is not halted here anywhere. So what we want to do to prevent that from happening, we can make the robot stop whenever we press a different button. So we will create a different callback method here, for example wrap up, and we will actually move this here, and don't forget to remove the waiting part here. And we want to register a different button here. So I will just copy this and we'll look up the one here. So I will just go back here and I see the rear button. So that's the back button at the head. I will just use that one. So I will change middle to rear. Change this callback to wrap up. And then now, if we are successful, we can make the robot stand up and crouch down again, stand up, crouch down again, while it's saying I'm going to crouch and going to stand now. Until we're finished with it, doing that repeatedly, we can just press the back button and it will go to the resting position and stop. Let's just see if we have been successful. And again, I need to select these all and start. Alright, it's starting, standing, and it's going to the crouching position, which is not supposed to happen. So this is an important lesson, also for me to check. What went wrong is that I forgot to remove these two brackets here. So if you ever see this happen, well, we see it live now in the video, this makes these two brackets here make this method run immediately instead of calling it whenever it needs to be called. So we don't want these things here. So the autocomplete messed this up here for us. So now let's try again and see if we're successful now. Select these.
How in the world?
So now let's see what happens when I press the head button.
Are you going to crouch now?
Yes.
Are you going to stand now?
And let's see if it's also repeatable.
Are you going to crouch now? Are you going to stand now?
Yes, and we can just repeat it indefinitely, but we don't want it, of course. So now we'll just make the program stop by hitting the rear head button. And voila. So this concludes this video. So what we've seen today so far is the functionalities of the abstract connector, the basic connector, the action helper methods, and an example where we use different features of all these things. There is so much more possible, of course, but I encourage you all to just try it out, and if you have any questions, just approach the teaching staff and the TAs to help you out in exploring the framework. And I will see you in the next video about the speech recognition part. Right. Thank you for your attention and goodbye.